Hello guys, welcome to another section of Math. Today we are going to look at how to differentiate problems of this nature. When you come across derivative question that looks like this or that are of this nature, how to solve it. That is what we are going to look at in this video. The derivative of sine of natural log of x squared plus 3. This problem here, can be solved using what? The chain rule. But even with the chain rule, if you don't take care, you find it difficult solving, because the way the chain rule, like, if you don't take care, you won't be able to use it to solve. Because what are you going to let u for? Are you going to let let's say u be equal to this one or the whole of this? So you see, so if you don't take care, you won't be able to use the chain rule to solve this problem here. Yeah, the formula that can be used to solve this one is what? The chain rule. But how are you going to use the chain rule to solve it? Are you going to let u be equal to the whole of this, or what, this one? Well, you're going to find out. But here in this video, we are not going to use the chain rule, but you're going to use another approach which actually indirectly reflects the chain rule. How the approach is being used is indirectly what? Referring indirectly to what? The chain rule. It's not directly as the chain rule is being what? Used. The steps involved in using the chain rule is a little bit different from what? This. But at the end of the day, you see that the application of what the chain rule is what being seen in the approach that we are going to use. Okay, so why don't we get started and then find out how problems of this nature are what? Differentiated. So first, let's write our solution. Good. Now let's bring this one down here. All right, so we are going to let y be equal to sine of natural log of what? R squared plus 3. Okay. Good. Let y be equal to this one because of the approach that I'm going to use. Okay, so here we are going to use the substitution what? Approach. Yeah, you're going to use the substitution approach, and you could see that the moment we do the substitution, the problem here become very easy and simple to what? Solve. Yeah, it become very easy and simple to solve. Okay, so here we're going to do what? Substitution. We're going to let u be equal to this or the whole of this. Well, we are going to let u be equal to the whole of natural log of what? X squared plus 3. When we do that, differentiating sine of u won't be all that what? Difficult, because we all know the derivative of what? Sine of what? X or what? U. Okay, it might be the natural log of 4x squared. That might give us a little problem, but don't worry, it won't be all that difficult as maybe we'll be what thinking it will be. Okay, so let's do our substitution. Okay, now here we are not going to do another substitution. U is equal to natural log of x squared plus 3. Yeah, if you want, you can do another substitution whereby you can let's say m be equal to what is in the bracket here. Then you differentiate then u will be equal to natural log of what, m. Then you differentiate. Later on, then you multiply the two answers what together. Multiplying those two answers together what reflect the chain rule. Yeah, reflect the application of what the chain rule. That is why I said initially that what will be the approach that we will be using will indirectly reflect what the chain rule. Okay, so we have done that. Yeah, we have been doing that for a while. That is when we get something like this, we do another substitution, and then we get to know how answer to this one is what. Alright, but here we are going to differentiate this one directly without doing any other what substitution. Okay, yeah, we also have to try sometimes differentiating directly without doing any further substitution. Okay, because when we get the final answer, you know how the answer what came by, because maybe if you want to find out, you can do the substitution that we have been doing as usual. Maybe let this one be equal to another, differentiate this one also, and then multiply your two answers together. When you do it like that, you are going to get the same answer as we are going to get for this one when it's being differentiated what directly. Okay, so to differentiate this one directly without making any further substitution, or without making any further substitution, this is what we are going to do. We all know the derivative of this one, that is what du. But what of natural log, and then what? Let's say natural log of what? X squared plus 3. Differentiating natural log is easy. That is 1 over whatever, let's say natural log of p. That will be 1 over whole p. But here is the case, it's not whole p, but it's what? X squared plus 3. Good. What we are going to do here is that we are first going to differentiate what is in the parenthesis of what? The natural log. That is what? X squared plus what? 3. X squared plus what? 3. Now we are going to differentiate that one, and whatever that we will get, we will multiply by the derivative of what? Natural log of the whole of this. Okay, so when we differentiate x squared plus 3, we are going to get 2x. Now, to differentiate natural log of what? X squared plus 3. To make it very simple for you, I'm going to say this so that it will help us. This one has been differentiated and we had 2x. Now, just assume that the whole of x squared plus 3 is what? One variable. That is, let's say, k. Yeah, you just take it as that. Just take it as the whole of x squared plus 3 is just one variable. That is what? Let's say k. Now, when we take it as that, or when we assume it in that way, it will become something that we know better. That is, natural log of, let's say, p is what? 1 over p. So when we assume that the whole of this is k, it becomes something that we are familiar of. So natural log of, assuming this one is k, is what? Natural log of what? K. To differentiate natural log of what? K, that one will give you what? 1 over k. We are maintaining this one, but we are assuming in our head that here is what? Let's say k. Here is what? Let's say k. So when we differentiate and we are writing our answer, we just write 1 over. Instead of writing the k, we will just put this one there. I hope you are not confused. Let me say it again. I said the derivative of this one is just what? 2x. And that 2x is going to be multiplied by the derivative of natural log of what? X squared plus 3. And to differentiate the natural log of x squared plus 3, that is, To differentiate this one, that one without encountering difficulty, I'm saying that assume that we are familiar with something like natural log of t is equal to 1 over t. We just write 1 and we divide it by what? The t. Okay, so we just assume that the whole of x squared plus 3 is what? Let's say k. When we assume it like that, it becomes something that we know better. That is what? Maybe natural log of, let's say, x, and that will give us what? 1 over x. But when you differentiate and you are writing your answer, instead of writing the k, you just write what? X squared plus 3. And when you do that, you are actually what? Applying the chain rule. But that is why I said the application will be seen by as what? Indirectly. Okay, so the derivative of this one, assuming this one is k, and then we differentiate, you're gonna get 1 over, instead of writing the k, what is here? That is x squared plus 3. So you're gonna get 1 over x squared plus what? 3. Then we differentiate, then we multiply the derivative of x squared plus 3, which is what? 2x, with or by 1 over x squared plus 3, and that will give us what? 2x over x squared plus what? 3. So the derivative to this one is 2x over x squared plus what? 3. Okay, so we're gonna get du is equal to 2x over x squared plus 3 dx. Now we are done differentiating this one. So let's look at the original one. That is y is equal to sine of what? U. And we all know the answer to this one. This one is just what? Very simple to solve as compared to this one. Okay, so y is equal to sine of u or sine u, and we have to differentiate. Now when you differentiate this, you're gonna get what? Cos u. So dy is equal to cos u du. Cos u du. Now we are done with the differentiation. So here is what? Cos u. So let's go back to the x word. Okay, so you're gonna replace the u with this one, and then we will replace u with what? Natural log of what? X squared plus 3. Okay, good. Here we are having cos u, and u is equal to natural log of x squared plus 3. So when we come here, we just put natural log of x squared plus 3 here, and when we do that, we're gonna get cos of natural log of x squared plus 3. Then we multiply by du. What is du? Du is what? Du is equal to 2x over x squared plus 3 dx, and that is the one what here. So what are we going to do? So let's just multiply. Let's multiply and find what we are going to get at the end of the day. Good. Now dy over dx is now equal to 2x times cos of natural log of x squared plus 3 all over x squared plus 3. Okay, so the answer to the derivative question is just 2x times cos of natural log of x squared plus 3 divided by or all over x squared plus 3. Okay, so that is the answer to the derivative question. You see, the substitution that we made make the what problem very simple for us to what solve. Okay, So let's end it. Therefore, the derivative of sine of natural log of x squared plus 3 is equal to 2x times cos 2x times cos of natural log of x squared plus 3 divided by x squared plus what? 3. Okay, so when you get problems of this nature and you don't want to use the chain rule, you can use the substitution approach to solve it, and I hope you have now know how to apply the substitution approach in solving problems of this nature. I mean, when you get something like this, you now know how to apply the substitution approach to solve it. Okay, all right, that's it guys. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching. Bye, and I will see you in another video.